Hey everybody, welcome back. And this is day 3, remote learning. On Friday you looked at the activity series, and that's basically a list of metals from the most active to the least active. So remember, on that list, things at the top of the list, there we go, are metals that are really active, they're extremely reactive, and as you go down that list, the metals become less reactive, less active. Okay. Today's lesson is kind of related to that, and we're going to look at what's known as metallurgy, which is basically working with metals. So let's take a look here. We've got some slides. There we go. So metallurgy is basically the study of metals and the practice of removing metals from ore and from minerals. That's metallurgy in a nutshell. Metals have been used for a long time, literally for thousands of years, and metallurgy basically is the different ways we have of getting metals from where we find them, or mineral, whatever. The activity series relates to this because depending on how active the metal is, that's going to affect how we get it from an ore or mineral. So what's an ore? An ore is a rock that contains minerals with important elements. Things like aluminum, tin, iron, whatever. And these often include metals that we can get and then sell for a profit or use in some practical way. So when you hear that word ore, this is specifically what we're talking about. Okay, a rock that contains a mineral with important elements. What else? Oh yeah, here's an example, iron ore. So as the name suggests, iron is contained in this rock. If you do certain things to it, you can get the iron from the rock. So that's iron ore. We also have minerals. The difference here, ore can be a mixture of different things, like you see there. A mineral usually is represented by a single chemical formula. It's a natural substance, it's stable, and it's a solid at room temperature. Okay, you might remember ionic compounds from much earlier in the year. Ionic compounds, or many minerals, I should say, are ionic compounds. Okay, and this may contain elements that are valuable, like metals. The example pictured is aragonite, which is calcium carbonate, CaCO3, and it contains the metal calcium. So if you do certain things to this aragonite, you'll get calcium from it. Now we also have what are known as alloys. An alloy is a mixture of a metal and at least one other element. The reason we make alloys, it makes metals stronger, more durable, more useful, or gives it some desirable property, durability, strength, whatever. Metal alloys are often more useful and more durable than a single metal, a pure metal. This is a diagram of an alloy on an atomic level. Technically, alloys are mixtures. You take two metals or one metal and some other element, and you liquefy them, you mix them, and then you allow it to harden and freeze. And then, within the pattern of metal atoms, you have atoms of another element that are mixed in. And a lot of times the other element may fill gaps, excuse me, in the other atoms, and that makes the material stronger. So this is the diagram of an alloy on an atomic level. Okay, remember, alloys are mixtures. Some examples: white gold, which is gold mixed with nickel. It is a mixture, but it gives it the white appearance, makes it strong. White gold. Brass is another one. Hold on. Oh, there we are. So brass is a mixture of copper and zinc, and it makes them both more durable than they would be on their own. It also makes it really shiny. Brass can be polished and has a very, very nice shine to it, luster, if you will. So those are alloys. Another one, steel, which you're probably familiar with. Steel is used for many things. It's a mixture of iron, carbon, and occasionally other elements. So an alloy is a mixture of a metal and at least one other ingredient. Okay? What else here? So the next couple of slides deal with techniques for removing metals from ore and from minerals. How do you get the metal out? So pyrometallurgy, you may know that the prefix pyro refers to heat and fire. So pyrometallurgy is a process where heat is used, and the heat may separate the metal from a mineral. Okay? The heat might also purify metal. And we often use this on metals that are low, there we go, on the activity series. Okay? And the reason why metals that are low on that activity series, if the metal is not very active, you may often find the metal in its pure form in nature, or in little pieces of its pure form. So by heating the rock that the metal is in, you can simply melt the desired metal, and then it'll just flow out of the rock, for instance. Or if you heat a metal, impurities in the metal may separate from the rest of the metal when you liquefy it. So pyrometallurgy, basically, we're using heat and fire to separate metal from a mineral. And all you need, with a good source of heat, you can do this method. This has been used for a long time. Hydrometallurgy, we're using solutions, water-based water-based solutions to get the metal from the mineral. So the way this works is that typically the mineral is dissolved, usually in an acid, and then either electricity or more active metals are used to get the desired metal from the solution. And with the more active metal, what you can do is if you dissolve a metal and its mineral in a solution, and then you put in a metal that's more active, that less active metal will actually solidify as a pure element. So that's another way of getting metal from a mineral. Hydrometallurgy, using solutions, often things like acid. Okay. One more method is known as electrometallurgy. Electro referring to electricity. Okay, as you can see there. Here's an example. You may remember a month or two ago in lab, we took sodium metal and put it in water, and we watched the reaction. Now, sodium metal rarely, pretty much never, occurs in nature in its pure form. Usually it's part of a compound like NaCl, sodium chloride. So the way a Downs cell works, that's what you see here. You take sodium chloride, table salt basically, and you run an extremely strong electrical current, through the salt. And with enough energy from the electrical current, you can actually give electrons back to the sodium and to the chlorine, and the elements will separate from each other. You'll get pure chlorine gas formed and pure sodium metal. So that's a method where if you run electricity through a compound, you can separate it into a metal and the other non-metal that it's bonded to. So that's an example of electrometallurgy. Here's what one actually looks like. And there it is. So in electrometallurgy, we're using electricity to get the metal from the mineral. And this is often used to harvest metals that are high on that activity series, things like sodium and calcium and lithium, etc. So that's a really basic overview of metallurgy. How do we get metal from ore and minerals? Okay. So what you're going to do here, there's a copy of this presentation in Classroom. There's one additional video you're going to watch. It's an Edpuzzle. So as you watch it, you're going to answer questions, and then at the end of the lesson, complete the worksheet in Google, the Google Doc worksheet attached to the lesson. All right, thanks everybody. I hope you're staying safe. Hope you're finding some way, to keep sane. Enjoy the nice weather, and I will see you later. All right, take care, everybody.